So here's a question for you guys. How do you graph 3 lines and see where they cross? You can't. Could you use the substitution method on this guy with 3 equations? Yep, but it's crazy hard. Could you use the elimination method? Yep, also extremely hard. So believe it or not, Cramer's rule, although lengthy, might be the easiest way to go here. So notice all the equations have all the variables on one side, x's in the first column, y's in the second column, z's in the third column, and the answers, if you want to call them that, -1, -9, and 5 on the end. So if we are doing a 3-equation problem, we want to make up matrices that are 3 by 3. Here's how we do it. If I want to find the x answer, I would leave out the x terms. I know it sounds weird, but instead of writing the 3, the -6, and the 9 in its place, I'm going to write the -1, the -9, and the 5. So the answers, if you will, go in place of the x's. Now the y's, since I'm not trying to find the y right now with this matrix, I'm going to leave, there's 1y, 5y, -2y. And in the z column, there's 1z, 3z, -1z. So I want to find the determinant of that, which I will do so momentarily. Okay, also need a y matrix. So again, the key is to leave off the y. So I'm going to do that first, that middle column. So instead of writing any y coefficients, I'm going to put the guys on the end, the -1, the -9, and the 5, in their place. But I will keep the x's, 3, -6, and 9, and I will keep the z's, 1, 3, and -1. Okay, let's do a z matrix. So this is a lot of work, but if you knew how to do this on a graphing calculator, in fact, I've already done that, I have it sitting right next to me, I would have just typed these numbers in, and it would be insanely easy. And if you have a graphing calculator, stop by and I'll be happy to show you how. So again, if I'm looking for the z's, I want to leave the z coefficients out. So I put that -1, that -9, and that 5 in place of them. But I leave the other ones. So I keep the 3, the -6, and 9. I keep the 1 and the 5 and the -2. And I just need to find the determinants. Okay, now lastly, to do Cramer's rule, you need to create a matrix in which you're going to divide by. I didn't change up colors. Why didn't I change up colors? I don't know. Let's do it now. So on this one, I want to use the other combination of numbers. So each time I've used the -1 and the -9 and the 5 so far, this time I'm going to leave it off. So since this determinant is not to find any of the letters, I leave the x's, I leave the x coefficients, I leave the y coefficients, and I leave the z coefficients. So each matrix has a set of numbers left off. All right, now, this takes way more than 10 minutes, my allotted time for this video, to do all these. So I'm going to do the first determinant only, just to remind you how to do them. And I'm going to cheat, and I've already had my calculator do the other determinants. But if you recall, to do a determinant, we would repeat the first 2 columns, so that -1, -9, and 5. Got to repeat those. So if you forget how this goes, you can always go back to video number 2, which does show you how. I'm going to show you one more time anyway, right? So how do you do a determinant? Wow, what happened there? I have no idea. You take the right diagonal, times them all together. So -1 times 5 times -1 plus the next right-facing diagonal, which is 1 times 3 times 5 plus, well, that's a terrible 5, third diagonal, which is 1 times negative 9 times negative 2, and you combine those. So let's see, this guy right here will be 5, plus this guy would be 15, plus this guy would be 18. So that's a total of 38. And then we do all the left-facing diagonals. So I'm not going to write them out. I'm just going to do them. 1 times 5 times 5, 25. Plus negative 1 times 3 times 2 will be 6. Plus 1 times negative 9 times negative 1 will be 9. And that equals 40. So do you remember what we have to do with the right-facing diagonal and then the left-facing diagonal? To get the determinant, you were supposed to subtract them. So if I subtract them, I get negative 2. So here's what I'm going to do. I'm going to write this over here. The x determinant ended up being negative 2. Again, no way I have time for this, so you're just going to have to trust me. If we went through the same process with the y, it ends up being 12. If we did the same process with the z, it ends up being 3. And if we did the same process with that last one, that z determinant, it ends up being negative 9. So a lot of work, but if you had a graphing calculator, it's just a matter of typing in a bunch of numbers and hitting a couple buttons, and you would have all those numbers. So to wrap this up, this is how we find the actual answers. So the negative 2 is not the answer, the 12 is not the answer, neither is the 3. So if you want to find the x coordinate, you take your determinant from the x, which was negative 2, and divide it by the D matrix. So that last matrix, and again, the reason I call it D is because it's the guy you're supposed to divide by. So negative divided by negative is positive. 2/9 does not reduce. Hey, 2/9 is my answer. You want the y coordinate? We take the y answer, which was 12, divide it by the dividing determinant, which was negative 9. So let's see, that fraction does reduce. I could divide by each top and bottom by 3, and he would reduce down to 4/3, but he's negative. And the z answer will be take the z determinant, which was 3, divided by the other guy, and that reduces to negative 1/3. So check it out. That's the 3 answers to the problem. If you were to plug those 3 fractions in for x, y, and z, it would come out true. They would check out. Again, for matrix, the best way to write these answers, what I was trying to get at, is you write them in what's kind of looks like coordinate form. So you have the 2/9. Having a heck of a time here, huh? 2/9 was the x answer. Negative 4/3 was the y answer. And negative 1/3 was the z answer. So there's the best way of writing that. But imagine, rather than all this work you would have gone through, if you knew how to just type these numbers onto a graphing calculator and hit enter, and it would have told you those 3 fractions. So Cramer's rule, kind of a cool deal. 4 equations make 4x4 matrices. So that brings us to the conclusion of the matrix chapter. Thanks for watching as always.